Welcome, e-learners. This is 9.5 homework part 2. I'm going to just focus, it's not going to just be page 3, I'm going to focus on 47 through 63 because they kind of go together. This is very, very new, but it ties into a lot of old things that we've done. Here we are to convert from rectangular equations that are in our wheelhouse. Like, we know that's a circle with radius 3, center 0, 0. We know this is a line. We know this is a line. We know that, we might not know, but this thing ends up being a rational expression. So anyway, functions that we would enter in our TI 93 or just involve x's and y's, and we want to turn those into polars. And polar equations are equations that, well, here's rectangular, xy. This is rectangular, and we want to be able to convert to and from polar, and polar equations have a radius, or how far we're throwing the rock, and an angle measure. What direction are we? We want to be able to convert x's and y's into r's and thetas. And at first that might sound really complicated, but there's some things we know. If we go back to our 2 a.m. wake-up calls, I told you this stuff was important. That's why it's a 2 a.m. wake-up call. You want to know this in the dead of night. Sine is y on r. Cosine is x on r. Tangent is y on x. And therefore, if I'm given an equation in rectangular form that's, let's say, it's 3y on x. Well, 3y on x could just be converted to 3 times tangent of theta. But more often than not, we're going to use these ones where if I cross multiply this, I get y equals r times sine of theta. So y may be converted into r sine of theta. And likewise, cosine of theta, or x, may be converted into, x may be converted into r cosine of theta. And y on x may be converted into tangent of theta. It just doesn't pop up as much. And one other thing we know, x squared plus y squared equals r squared. Any place we build those, we get an x, we get a y, and we get an r. And we're always in that Pythagorean relationship. So let's go ahead and get started with this. Right out of the bat, they give us x squared plus y squared. So that is r squared equals 9. And algebraically, we'd say r equals plus or minus 3. Let's think about that. That means that r, we're going to throw the rock forward or backwards 3, and we can rotate however much we want. Which means I'm sitting here with rock in hand, I'm aiming out this way 0, I rotate a little ways, I throw it 3. I throw it 3. I keep rotating, keep throwing the rock 3, keep throwing the rock 3, and of course, sure enough, we get that circle. Notice I never said throw it backwards. Now I could have rotated this way, thrown 3, or thrown backwards 3, and I'm still on the circle, but truthfully, we could just say the solution to this is just plain old r equals 3. It's not wrong to say plus or minus 3, it's just extraneous. Okay. Likewise, this is probably easier to do without conversion, but I'm going to convert it. Y is r times cosine of theta. X, no it's not, y is r times sine of theta. X is r times cosine of theta. Divide by r, I get sine of theta equals cosine of theta. When does sine of theta equal cosine of theta? Well, don't forget, this is y on r equals x on r. So that can only happen when y equals x and we're right back home. Well, when does y equal x? Y equals x when we are right here. On that line, y equals x. Kind of a weird one, but if we build a triangle, we could say, well, that happens right here at 1, 1, square root of 2, or at -1, -1, square root of 2. Anyway, I want to just throw my rock in that direction or in that direction. I either want to be at pi on 4, throw my rock, or 5/4 pi, throw my rock. But what if I was just aiming this way, I throw my rock, so I'm saying this, pi on 4, I throw my rock any distance I want forward or backward. So the answer to this, best answer is just state is, hey, just aim pi on 4, throw the rock forward or backwards. So special case there. Lots of times we're going to have r's and thetas in our answer. Okay, y, that is r sine of theta equals a. If it's convenient, if it's at all convenient, it's proper, it's considered proper to solve these things for r. So I get r equals a on sine of theta, which is not a bad answer, but probably not the best answer. Maybe if this was a 5-point problem, that would be -1. Best answer is r is a times cosecant theta. And my screen froze up, and hopefully I'm still here. Okay, we're good. So r equals a cosecant of theta, best answer. This one pretty good. All right, 53. 3 times r cosine of theta. Remember, cosine is x on r. The r's would cancel, so that's just 3x. Minus r sine of theta plus 2 equals 0. If I'm going to solve this for r, I'm going to isolate my r's on one side, factor out r. 3 cosine theta minus sine theta equals -2. R equals -2 on 3 cosine of theta minus sine of theta. So that's our relationship. We can put theta in and get r out. And we've got it. Somehow, surprisingly, this must graph, when we do as a polar, to end up being a line, which seems crazy. With all the curves that are going on here, they kind of cancel each other into just a line. Okay, 55 with a little sneaky twist to it. Boy, this would be a great extra credit problem. So this would be r cosine of theta times r sine of theta equals 4. That's r squared equals 4 on sine of theta cosine of theta. And that actually, I'd be pretty happy if we just got to there. This would be where I might say, okay, solve this for r squared, but I want it in simplest form, and this is really sneaky. Times 2 times 2. Clearly, this would reduce to 4 on. Clearly, we still have the same answer here. Does that ring a bell at all? R squared equals 8 on sine of 2 theta. There's our double angle pre-Christmas formula that we have not touched since then. And that would be a better answer than this, but even better than that, r squared equals 8 times cosecant 2 theta, the reciprocal. And then it's just a debate whether you want to have r equal the square root of, plus or minus square root of. But this is actually the book solution right here. It would not be bad to say r equals the square root of all of that. And you really honestly don't have to say plus or minus square root because of our discussion up here. Throw the rock forward, throw it backward. Okay. X squared plus y squared. You don't get that opportunity very often, but we had it up here. X squared plus y squared is r squared. So 57, this is r squared squared equals 9x squared minus 9y squared. That is r to the 4th equals 9 times r squared cosine squared theta minus 9 times r squared sine squared theta. Divide both sides by r squared. R squared is, I'm going to divide out those r squareds and factor out a 9. 9 times cosine squared theta minus sine squared of theta. And that's a good answer right there. This would be another one. This is going to call on a double angle formula. Maybe that was a big enough hint to recognize this one. This is r squared equals 9 times cosine 2 theta. Best answer. To be perfectly honest with you, at this time I would be pretty happy if you made it to there. So perhaps extra credit opportunities coming on that. Okay, let's continue on through these next 3 problems, same section. X squared plus y squared, love it. R squared minus 6x is r cosine of theta equals 0. And ideally we would solve this for r. What could we do? I could divide both sides by r, and I get r minus 6 cosine of theta equals 0, or r equals 6 cosine of theta. Well, that wasn't bad. And if that wasn't bad and you came here for that problem, you should be able to do 61. There's no secret. This A is just going to go along for the ride. R squared minus 2 times A times r cosine of theta equals 0. Divide r, divide r, divide r, divide r, and add 2a cosine of theta. And 63. Y is r sine, so this is r squared sine squared theta equals x is r cosine, r cubed cosine cubed theta. Let's see, if I divide both sides by r squared, sine squared theta equals r cosine cubed theta, divided both sides by r squared. So I get r equals sine squared of theta on cosine cubed theta. Not bad. Can you come up with a way to simplify that? If not, here's a hint. R equals, how about sine squared of theta on cosine squared of theta times 1 on cosine of theta? Best answer. So short video there, but I wanted to cover that section. The next section we're going to do, as you can see, just convert polar back to rectangular. Maybe a little sneakier, but very similar.